Today, we're going to go on a little detective journey. We're not just looking at sixth grade math tests to see the scores. Nope. We're looking for the clues, the patterns, and the stories that are hidden inside the data. Clues that tell us exactly how students learn. It sounds a little like science fiction, right? But what if I told you that in a way, it actually can? By analyzing not just if an answer is right or wrong, but the type of wrong answer they choose, we can get this fascinating peek into a student's actual thought process. And that's our whole mission today, to decode these stories. You'll see that when a student gets a problem wrong, they're usually not just guessing. They're actually following a path that makes sense to them, but it's flawed. And by finding that one flawed step, we can pinpoint the exact moment where understanding breaks down. To do this, we're going to open up two case files. On the left, we've got the world of ratios and proportional reasoning. You know, problems about books and dogs and money. And on the right, we're diving into the tricky domain of geometry, calculating the area of all kinds of different shapes. Let's see what they can teach us. Okay, first up, the ratio riddle. You know, ratios are literally everywhere in the real world. From cooking to shopping, they seem pretty straightforward. But as we're about to see, one tiny little twist can make a huge, huge difference.
Let's start with a problem that most students actually handle really well. So here, we're looking at Liana's earnings. To solve this, a student has to figure out her hourly rate from the table and then just apply it to a new number of hours. It's a pretty classic rate problem.
And look at that. 58% of students nail this one. They correctly figure out the unit rate, which is $22.50 an hour, and they scale it up. So this tells us that, yeah, a majority of sixth graders are pretty comfortable with basic proportional reasoning. So what's the mystery?
Well, the mystery begins with this next problem. It looks very similar, doesn't it? We have a ratio, 4 large dogs to 3 small dogs, and we have a total. The question's just asking for the number of small dogs. Seems simple enough, right?
But it's not. The success rate plummets to just 35%. That is a massive drop from the 58% we just saw. So what is going on? What is the hidden trap in this dog show problem? Here's the key. It's all about the difference between a part-to-part and a part-to-whole ratio. The question gives a part-to-part ratio, 4 parts large dogs to 3 parts small dogs. But to solve it, you have to think about the whole. So 4 plus 3 means there are 7 total parts. That means the ratio of small dogs to the total number of dogs is actually 3 out of 7. So many students miss that little conversion step, and that's the key to cracking this whole case. Okay, now let's move on to our second case file. And you're going to see a really similar pattern here. Welcome to the shapeshifter, where geometry problems can be a lot more than they appear. Areas seem simple. You just plug some numbers into a formula. But as we'll see, the complexity can ramp up fast. And just like before, let's set a baseline. Here's a problem asking for the area of a trapezoid-shaped lawn. The shape is clearly defined, the numbers are right there, and students just need to apply one specific formula. And they do it pretty well. 63% of students get the area right. So this shows that when the task is clear, one shape, one formula, students are generally successful. But now, look at this. The task is no longer about finding just one area. Here, students are being asked to find which 2 of these 5 different shapes have the exact same area. This requires so much more work, 5 separate calculations, and then you have to compare them all. And the success rate tells the whole story. Only 25% of students get this right. Wow. The amount of thinking required has just skyrocketed, and you can see the performance drop dramatically. The big question is, why is this so much harder? You know, what's really interesting here is how subtle the challenge can be. Just look at the formulas for the parallelogram and the triangle. They are almost identical. The only difference is that tiny little 1/2 for the triangle. In the middle of a test, that is such an easy detail to forget, but it's the critical difference between getting it right and getting it wrong. So the real culprit here isn't one single big misconception. It's the sheer number of steps involved. A student has to correctly identify each shape, then pull the right formula out of their memory, plug in the correct numbers, and make sure they're using height, not the slant length, and then do the math perfectly. A breakdown at any one of those stages leads to a mistake. All right, so we've diagnosed the problems. Now for the good part. What's the solution? Well, this is where great teaching comes into play. Educators have this whole toolkit of strategies designed specifically to tackle these common stumbling blocks.
This right here is a perfect example of one of the most powerful tools in that toolkit. For that tricky part-to-whole ratio problem, a visual model like this double number line can make that abstract idea of parts something you can actually see and touch. It helps students see the relationship instead of just trying to juggle numbers around in their head. It all really boils down to a few core strategies. For ratios, you start with unit rates to build a really strong foundation before you move to the complex stuff. For geometry, you focus on the properties of the shapes themselves, like what actually makes a parallelogram, before you even touch a formula. And for both, you use visual models, you build up from simple to complex, and you insist on precise language. It's all about building that understanding brick by brick.
So why does all this matter so much? I mean, why do we spend all this time analyzing these sixth grade problems? Well, because it's not really just about sixth grade math.
Think about it. Proportional reasoning is the absolute heart of algebra and physics. Understanding area is critical for things like architecture, design, and engineering. Getting these fundamentals right in middle school is absolutely crucial for success later on, not just in school, but in the real world. And that brings us right back to our main idea. Cracking the code of these tests isn't about judging students or teachers. It's about getting the insight we need to teach more effectively. By understanding where the common pitfalls are, we can build bridges to help students get across them.
This chart just lays it all out, doesn't it? It perfectly summarizes our whole investigation today. For both ratios and geometry, we see students doing pretty well on the straightforward, single-step problems. But the moment you add a layer of complexity, either a conceptual twist or just more steps, a really significant learning gap appears. And our job as educators and parents is to close that gap.
This whole process just goes to show you that data isn't just a boring bunch of numbers. It's a collection of stories. And it really leaves you wondering, if we can learn this much from a simple math test, what other powerful insights are just hiding in plain sight all around us, just waiting for somebody to ask the right questions?